Lesson is we're going to figure out what the end behavior looks like for our exponential functions. So we know what our rational functions look like, right? We were always approaching some asymptote. After studying those, graphing a lot of those, we now know what they look like. We want to be able to say the same about our exponential functions. What do those typically look like? So it says we will have them given to us in this form, f of x, which remember also is the same as y, is equal to b to the x. B is just representing the base, right? It could be a number, a variable, right? We've seen some of both. And then x is your exponent, so it should be written up here. So it says, given the exponential function y equals 2x, enter this function into a graphing calculator and use the ask mode to complete the table below. And then draw the graph of the function. So we're going to go and type this equation into y equals in our graphing calculator. So we'll have 2 raised to the x power. All right. Now these are simple numbers, so you don't necessarily have to really fix your table set to anything specific. So you could just pull up your table. When it talks about the ask option, that's if you press second window, and then you can say what you want it to start at. So like our first value is 0, so I could put that I want it to start at 0. Then the triangle TBL means how much you want it to change by each time. Well, ours is changing by one number each time, right? So we'd put a 1 there. And then you can pull up your table, and that's where it'll start. So remember, to pull up your table, you just press second graph. All right, so we got our table of values here. When x is 0, what is y? 1. All right. Oops, got the highlighter on. Okay, what about when x is 1? 2. And when x is 2? 4. And what about 3? 8. And 4? 16. And these all make sense, right? We know that's what happens if you raise 2 to any of these powers, right? Okay. What about 5? 32. All right, and now it starts increasing by bigger amounts. So if you want to go back to second window, you can say you want it to change by bigger increments. So now it's going to increase by increments. Let's say we want it to change by increments of 10, and we want it to start at 10. So I would change both of them to 10 and pull my table back up. So when x is 10, what is y? All right, what about when x is 30? It has E, right? That just means it's in scientific notation. Basically, what that means, if I were to write it up here on the board, is it says, what is it, 1.07 e to the 9? Right, is what it says, basically. So all that means is move the decimal places 9 places this way. Well, the first time I move it over, it just puts it in front of the 1, right? But when I move it over after that, there's not anything there, so I'm going to have to put zeros as placeholders. So I'd have a 0, or, oh wait, sorry. This one has a positive 9, so I'm moving the other direction. I apologize. The exponent's positive. I'm moving this way 9. So on and so forth, okay? So it's going to be a really big number. If that exponent was a negative 9, I'd move the other direction. I apologize. Okay, so just basically know it means it's a really big number because I'm going to be adding a bunch of zeros on the end. Okay, so we said it was 1.07 e to the 9. Okay, what about 50? Okay. 1.1 e. All right. Okay. Now, in this second column, it basically would have listed 0 again, but we already had that point. And now it's going to start going in the other direction, right? So into the negatives. So you might go back to your table set, so second window, we want it to start at -1, and we want it to change only by 1 again. And then I can pull up my table. And when x is -1, what do we get for y? 0.5. All right, what about for -2? 0.25. All right, and then for -3? And -4? Right. And -5? All right, and then we get to -10. So you can change your table set again, or you can scroll to -10, either way. What does it say for -10? Right. So since this time the exponent, the e, is negative, that would mean that we're moving the other direction. So 9.8 e -4 means 4 places this way. So 1, 2, 3, 4. Basically, I'm going to have to put 3 zeros in front of it, right? All right. So a really small decimal. Okay. What about at -30? What do we get? Okay. All right. And then what about for -50? Right. Perfect. So it just keeps getting a smaller and smaller decimal, right? More and more zeros in front of it. Okay. So in other words, in this column, it got extremely big, right? And in this column, our y was getting extremely small. So it says as our x value was going off to infinity, that would be positive infinity. So that would have been these numbers, right? What was y headed off to? Also infinity, right? It was getting really, really big. So as the x's were getting really big, right, got all the way up to 50, we could have kept going if we had more space in our table. The y values were doing the same. Now this one's a little bit trickier because yes, it was getting really, really small, but not really small like -1 million, right? It was just getting to be a smaller and smaller decimal, right? So if you look at your table, I only went from 0.5 to like something like this, right? So what number is it getting really close to? 0, yeah. So while our y values in this column were getting huge, right? No cap to the number, right? It just kept getting bigger and bigger. These numbers were getting smaller, but they never went past 0, right? Okay. So that being said, we have a horizontal asymptote at 0, right? That's what's going to keep it from going past there. So therefore, we have a horizontal asymptote at y equals 0. Remember, horizontal lines are y equals a number, right? Okay. So keeping that in mind, they say to draw a graph of our function. So I'm going to plot a couple points that we had on that table. Clearly, they won't all fit, but we can do a few. So we know at 0, 1, we had a point, right? So I'll plot a point at 0, 1. At 1, 2. And 2, 4. And 3, 8. But that's about all that'll fit for the positive numbers, right? Okay, going the other direction, at -1, we had a point at 0.5. So right about here. And then after that, at -2, we had one at -0.25, right? After that, it's going to get kind of hard to plot the points and make them look any different than the one before it, right? But we did say that we have a horizontal asymptote at 0. So remember, that means there's this imaginary line right here that it's going to get really, really close to but never touch, right? Okay, so my graph looks something like this, right? Okay. All right, let's do one more so that we can get an idea of what these generally look like, even if the numbers change a little bit. All right, so flip it over on the back. This time, it says for your function that you're going to use 0.5 raised to the x. So you're going to go into y equals, clear out that 2 to the x, and make it 0.5 to the x. All right, and we're going to do the same thing. We're going to fill in this table with that information. So when x is 0, what do we get for y? 1, okay? What about when x was 1? What do we get? 0.5, All right, what about when it's 2? 0.25, okay. When it's 3? And 4? All right. And 5? All right, and then when I get to 10, we start having it in scientific notation, right? So what was that one? 9.8. Good. Okay, and that -4 means my decimals are going in front, right? So I'm adding zeros to the front of the number, right? So it's getting smaller. What about at 30? What do we get for 30? Good. And for 50? So eventually you're going to have to add 15 zeros in front of it, right? All right, so in other words, as x in this first column was getting really, really big, it says going towards infinity, what was this y column doing? Getting closer to 0. Very good. Okay, now we're going to do the same for the other columns. So when x is -1, what's our y value? 2. What about -2? 4. Okay. And then we get 8. 16. Very good. All right. All right. All right. So since these have positive exponents, right? That's going to be like this. It's going to add zeros to the end, so it gets to be really, really big. So in this case, when these x's were getting smaller, right, headed off to -infinity, what were the y values headed towards? Positive infinity. All right, so again, it looks like we never go below what value? 0. So that must mean that, again, we have this horizontal asymptote. At y equals 0. Okay. So now it wants us to draw this graph. So again, we can't fit all the points, but we can fit a few. So we would have the point 0, 1, 2, and 0.5, 3, and 1.25 is pretty low. Okay, but then when we go in the negative direction, we got a point at -1, +2. We got a point at -2, +4. And at -3, +8. So like we said, again, there's this imaginary line, an asymptote at 0, telling us it cannot pass that line. So it's going to look something like this. Okay, so it looks pretty similar to the one we did on the front page. What would you guys say are the similarities and the differences? Both of them are what? Okay, both of them have a y-intercept at 1. Is that what you're talking about? Mm-hmm. One's what? Okay, they both have an asymptote at 0. So those are some good similarities. What's the difference between these two graphs? They're going in opposite directions. Yeah. Okay. So do you guys think there's any rule that we could follow to know if it's going to curve to the left or curve to the right?
It's below 0.
Yeah, if it's going to be like something like a decimal or a fraction, right? So not necessarily below 0, but anything below 1, right? Like 0.5 is between 0 and 1. That's probably going to make it turn that direction, right? Because think about it. A decimal is the same as a fraction, right? And whenever we have a fraction, it usually originally starts out like this, right? But we don't like a negative exponent, so we move it to the bottom, right? That's what makes it happen, right? So when you have decimals, that's because you had negative exponents, negative x values. So it's going to go off onto that negative side. But if your base and your exponent is a whole number, like 2, or even something bigger, like 2.75, right? It should go this way, right? Because it's not going to necessarily get smaller because I'm plugging in positive x values, right? Okay. All right, so now we can kind of anticipate what our graphs will look like. All right.